Under 3.3, we need to know how to use sec x, cosec x, and cot x. And we need to be able to simplify expressions and prove identities and solve equalities involving sec x, cosec x, and cot x. And of course, you must be advised when we are having sec x is equals to k and cosec x is equals to k. These two, you must remember that they have no solutions. They have no solution when k is greater than -1 and less than 1. You realize that we were talking about sketching the graph of these functions, and -1 was only acting like a turning point, and +1 was acting as a turning point. There were no values of y for this particular region. That one you must remember. In example 6, we are supposed to, there's a part A, we are supposed to simplify something to do with sine theta, cot theta, sec theta. You're supposed to simplify that. And in an attempt to do it, you realize that sine theta is a primary trigonometric ratio and it remains that way. So sine theta, cot theta is a secondary ratio, so that means 1 over tan theta times sec theta, which is 1 over the cosine of theta. At that point, you realize that there is nothing much you can do with these trigonometric ratios. So we need to work on that, because this one has a different name. 1 over tan theta is simply cosine theta over sine theta. So rewriting everything afresh, we have sine theta times the cosine of theta over the sine of theta times 1 over the cosine of theta. And at that particular point, this one is obviously over 1 or naturally over 1. Sine theta cancel out. Cosine theta cancel out. And this is simply a 1. And that is how we can simplify sine theta, cot theta, sec theta. Part B of the theme, example 6, part B, simplify sine theta, cos theta, open bracket, sec theta plus cosec theta, close bracket. In this particular part of the question, we may not so much have anything to do with these primary trigonometric ratios, but it is this part that we must work on, because these ones are already secondary trigonometric ratios. Meaning that if we continue now, we can probably deal with this part, the bracketed part only. This one gives us 1 over the cosine of theta plus 1 over the sine of theta. And when two fractions are being added together, we always go for the LCM, which is the cosine theta sine theta. And the numerator just becomes this LCM divided by the cosine of theta. It gives us the other, which is sine theta. So on the numerator, we are having sine theta plus the cosine of theta. Having written it that way, we must remember that it was being multiplied by the first part of the equation. So sine theta, cosine theta multiplied by sine theta plus the cosine of theta all over the cosine of theta sine theta, closing the bracket. And you can see, because these are two brackets being multiplied together, then it goes without saying that the sine theta cosine theta will cancel with the denominator. And what we'll be having at the end of the day is a simplified version of that relationship, which is sine theta plus the cosine of theta. So it is important to know how we can rewrite a secondary trigonometric ratio using the primary trigonometric ratio so that we can simplify the whole expression. That is now what we have, and that gives us our final submission as far as example 6 is concerned. So is equals to sine theta plus the cosine of theta. Okay.